All right, you don't need to have this note frame for these notes, although you can print it from the website if you'd like to. What we're going to look at today is creating tables using the ratio of change. So if you decided not to print this up, you can be taking these notes on a sheet of lined paper. So the first thing to remember is what it means for something to be linear. If a relationship is linear, then the key thing that we see is that ratio, right, the comparison using division between the change in the output values, which when we talk about xy equations, things like 3x plus 2y is equal to whatever, 12, we'll think about the output values being the y values. So it's the ratio between the change in the output values and the change in the input, or x values. If that ratio is constant, if it's always the same, then we know that a relation is linear. So here we have a table, and what it tells us here is that the table below contains three solutions to an unknown linear equation. So what that means is each of these pairs is a solution to some equation. We don't know what the equation is, but we do know that the equation is linear, meaning that that ratio of change is always the same. We can confirm that really quickly by comparing how much my y changes and how much my x changes. From 12 to 33, my y would change by what would that be, 21, and from 2 to 8, my x would change by 6. That ratio of 21 for the change in the output and 6 for the change in the input, or 21 for the change in y and 6 for the change in x, simplifies to not 7, to 7 over 2, meaning that for every 7 that my y changes by, my x changes by 2. We can see, if we want to, that that change is always the same by looking at the next movement that we have here, the next pair of values. So the change from 33 to 75 would be whatever 75 minus 33 is. That would be 42. And the change in the x would be 20 minus 8, right? It would be the difference, the change between 8 and 20 is 20 minus 8, which would be 12. Let's see here, both of those things can be divided by 2, which would be 21 over 6. And then they both have a 3 in them. So that would be 3 times 2, that would be 3 times 7. The 3's divide out to 1, and we have 7 over 2. So we see that it's linear because it has this same ratio of change. So now what they're going to ask us to do here is to find a bunch of other points that are solutions to this same equation. And we should be able to do that really easily with this ratio of change. Remember, what the ratio of change tells us is that, let's go ahead and put this maybe more in the middle, that for every 7 units y changes, comma, x changes by 2. Right? There's really what that ratio tells us. So what that means for us here is that if y changes by 7, so if we had 12 plus 7 would be 19, then my x would have to change by 2. 2 plus 2 would be 4. And this would be another xy pair that would be a solution to this same equation. We could find other values. When y changes by 7, 19 plus 7 is 26. When x changes by 2, we'd have 4 plus 2, which would be 6, plus 7 plus 6. We could go in the other direction, right? If y changes by 7 but it subtracts by 7, right, if it gets more towards the negative by 7, so 12 minus 7, then we should see 2 minus 2, right, that starting value minus 2, giving us 0 in the x. Pause the video now and see if you can fill in all of the rest of the values on this table. All right, welcome back from the pause. Here's what you should have. You should have -2 and -2. You should have 10 and 40, 12 and 47. You should have, there's the bell, 14 and 54. You should have 16 and 61. It looks like we didn't quite give ourselves enough room, but that's okay. We can add another one here. We would have 18 and 68, right? We can see that the pattern is still holding. We can go past that biggest value we had, 22 and 82, and 24 and 84. All of these values would be solutions to the same equation. And at this point, actually, we should be able to find this equation pretty easily. We know that our ratio of change is 7/2, so our output, quote-unquote output, our y value, is going to be 7/2 times x plus or minus something, right? How much would we be off by if we just multiply by 7/2? Well, the easy place to check is check 0, right? When x is 0, we're off by, this would be 0, so we'd be off by 5, plus 5. We can check the other things if we want to, right? 8 divided by 2 is 4. 4 times 7 is 28. 28 plus 5 is 33.